Now, suppose you are asked to determine the vertical component of the shell's velocity, probably 50 seconds later. That is from the previous question we solved in the other video about a gun that fires a shell at an angle of elevation of 30 degrees with a velocity of this. We've calculated the vertical, we found the vertical and horizontal components of the velocity of the shell, we found the range, we found the maximum height it attained. Now suppose this question was added. Determine the vertical component of the shell's velocity after 50 seconds, or determine the vertical and horizontal displacement of the projectile 50 seconds later. Now for this particular question, we need to recall this equation that will help us solve or determine the vertical component of the projectile's velocity. Now we can write Vy equals u sine theta minus gt, where t is 50 seconds. 50 seconds later, what is the vertical velocity? Vertical component of the projectile's velocity, that's Vy, which equals, this u was given as 2000 sine 30 minus 10 times 50. So that will give you 1000, because 2000 sine 30 is 0.5 multiplied by 1000, that is, by 2000, that gives 1000 minus 500. So the velocity of the shell after 50 seconds will be 500 meters per second. Maybe I can as well determine the horizontal component of the shell's velocity after 50 seconds. Recall that this one is Vx and remains u cos theta. Okay, that's Vx equals 2000 multiplied by cos 30. Because it does not change, that gives 1732 meters per second approximately. This one is constant. In the last video, we got it as this. It doesn't change. It remains constant throughout because horizontal motion is not affected by gravity, but the vertical component of the velocity keeps changing with time because of the effect of gravity on it. Now this one says, the second question, the vertical and the horizontal displacement of the shell after the same time, after the same 50 seconds. Mind you, the question reads that a gun fires a shell at an angle of elevation of 30 with a velocity of 2000 meters per second. Now we are asked to calculate the vertical and the horizontal displacement of the same shell after the same time, that is 50 seconds later. What would that be? Now, just like maybe I tried to demonstrate it using this diagram. Let's say this is the shell and this is a path taken by the shell. So 50 seconds later, we assume the shell is somewhere here at point A. How high has it risen? Of course, this is not asking for the maximum height risen. Let's say 50 seconds later, the shell is at this point A. We want to find distance y and distance x. That is what the question is all about. Now we have to invoke the equation for to calculate the vertical displacement at some given time t. That is ut sine theta minus half gt squared. I'm sure you remember this equation. I think this was derived in the second video of this topic. Now my y equals, this is 2000 times 50 times sine 30 minus half times 10 times 50 squared. So this y gives me sine 30 is 25, or sorry, sine 30 is 0.5 times 50 gives you 25, minus this cancel, that is 5, times square of 50 is 2500. So when I multiply 2000, by 25, it gives me 50,000. 50,000 minus, then I multiply 2,500 by 5, that gives me 125,000. By the time I subtract 50,000 from, I subtract 125,000 from 50,000, that gives me 375,000 meters. That's the vertical displacement of the shell after 50 seconds. And in kilometers, we can express this as 37.5 kilometer. That is dividing by 1,000. Then the other ones, the last question says we are to calculate the horizontal displacement. That is x. Let me solve it here. That will give me ut cos theta. We derived this equation in the second video so for this topic. So if you want to know more, I'll refer you to the second video of this topic where I showed how to derive equations for the horizontal displacement and for the vertical displacement of the projectile. So here now we use u as 2000 times 50 seconds times cos 30. That is the horizontal displacement x of the projectile. So if you multiply that, that gives you 2000 multiplied by 50 by cos 30. That gives you 86,603 approximately meters. And in kilometer, the horizontal displacement is 86.6 kilometer approximately. That's the horizontal displacement covered by the projectile, by the shell. So we'll see more questions in subsequent video.